Hi, hello, this is Piotr speaking, and on Quasar Training part 14, where I'd like that we talk about source variables, and for a little introduction to source variables. So, for the context, in part 3 or part 4, we looked at cache variables. And there I said that cache variables are variables which can represent process variables, so like a state of a thing, like last voltage or current voltage or last current, last pressure, whatever measurable state of process that holds over time. Okay, those were cache variables, and I also told you that technically cache variables were kept in the memory of the servers such that when you requested that information, it was always coming from the server's cache, server's memory. Here we talk about source variables, which is another kind of variables supported by Quasar. And source variables are used when you do information exchange in situation when there is no notion of current state. You don't have anything that could describe what's the current state, or a thing cannot be cached in the server's memory because it would not make sense. And in the next slide, I will give you a short example which will illustrate how this actually works. Let's now go via the difference. So when we compare like line by line source variables against cache variables, what we see is primarily what is the value when you read this. When a client reads a value, in the case of source variable, it's always handled by your custom code. So it's always passed. The query is always passed to the code that you're going to write in C++, while with cache variable, it's always taken from server's memory. You can change, in cache variable, you can change that server's memory, but whenever a client requests that, it's always taken from the memory, from the cache. In source, it's always handled by the custom code. When you ask where the value is written to, again, for source variables, always handled by the custom code, so there will be like a write delegate being called by the write transaction, and for cache variable, it will be passed to the server's memory. It can have a delegate, but in the end, if the delegate was finalized with a good status code, it will be stored in the server's memory. That's the primary difference. It's actually a huge difference, and about anything else is identical. And of course, few things that you see in cache variables, like the fact that they cannot be initialized, they don't really make any sense in source variable because source variable does not hold any value. So there is you will not find in the Quasar design anything which is like initialized from this, or what's the initial status, or blah blah. This you will not find because this does not make much sense for source variable. But apart from this, the data types are identical and the write delegate is identical, and voila. I'd like to remark here that source variables have a very nice side effect, which is that in Quasar, we've implemented it such that they can be called asynchronously. So all those, you see, I say this is always handled by custom code. Those things can be asynchronous, which means they can run away from the network thread, so they will be non-blocking your OPC-UA communication, and those things will cover in the next part, I think. In this part, we'll just focus on the synchronous parts, and still with the synchronous, we can find a couple of really good applications, interesting applications that you cannot do with cache variables. And one remark here, so this part requires building against UA SDK, and so you can see part 13. A short summary is that if you kept going through those slides with just Open 62501, at the moment, when I'm saying this, which is January 2020, you still cannot do that on Open 62501 in the way that Quasar wraps it. You need the UA SDK. In the part 13, if you refer back to it, you will find how you can actually get the evaluation version of UA SDK to see how this all behaves. So let's have a simple example, which I hope will let you understand how this all works. So I imagine the following situation. I want a a variable in the OPC-UA address space which would increase its value on every read, which means I want something like a unique serial number generator which exposes over OPC-UA the unique number. Each time I read, of course, it increases. And as you probably already understood, for this application, we cannot use cache variables because this would be, well, unreliable. The first question would be like, when do you increment? And you would have to synchronize incrementing with reading by clients, and this all stops really having any sense. So this is a prime example where having a source variable shines, to be more correct. Okay, so let's start developing something. So this is my Quasar OPC-UA server as of part 13. So for the simple example, I will add a separate class with just source variable example, but then as we go to asynchronous calls in the part that will be part 15, I think we'll integrate with our existing stuff of motor controller things. So what I do is I add a child class, and I call this class source variable example. And there, of course, I want the source variable. Okay, and I thought it would be a nice incrementer, so whatever integer could make sense. I call it counter, and then I have to fill those 4 things. So whether I can read, whether I can write, and whether to synchronize those things. So we'll skip synchronization, it's not really relevant at this stage, but for address space read and address space write. So I will say that when a client reads, I will allow this, and this will be synchronous. As I told you, in this chapter we do synchronous, and I will not permit to write anything. So I say it's forbidden. Okay, so voila. And also to have the device logic, to code the device logic, I need to actually indicate that I want this. And of course, I need to use this class in my project. So I add has objects, and I say the class is source variable example. Save. Then, as you remember, since I added a new class with device logic, I need to generate like initial logic, which would be source variable example. And then, well, let's actually see what it did. So I look at my device, and then if I refresh, you see I have source variable example. And for the body, I look in SRC, and again, I see source variable example. So what happens here? Look, there is you remember the parts which we don't really care much about, but then you see something new. It's called read counter, okay? Read counter, and then in the body, actually, you have that as well. And so for the moment, it's just bad, not implemented. It's a place where it's the read delegate for source variable. It's a place where you should place your implementation for what happens when there is an OPC-UA read on this variable. So since we wanted to have something like an incrementer, then what I will do is I will keep here my unsigned int counter. Okay. In the constructor, which I think is here, I will initialize this to, this is correct actually. Yeah, actually to keep the convention, this should be m counter. I will initialize this to 0. Oh God, what I'm doing here. Apologies. Sorry, it was not that well readable. M counter, I will initialize to 0. Okay. And this I save, of course. And then each time somebody reads, what I will do is I will increase it, and I will pass value to be the increased value. like that, okay? So of course you can have questions like, how is this guaranteed that two OPC-UA clients will not call a read counter at the same time? So this is not guaranteed yet if you run with possibly multiple threads processing different OPC-UA clients concurrently. But this of course can be done with Quasar, and this I'll show soon. But now we illustrating the basic principle, okay? So I skip that aspect for the moment. Okay, so now I build my server against the evaluation version of the UA SDK. So once again, in the part 13, you can have a look how do you obtain that. Okay, and now let's try to run our server and let's see what happens. And when I get back to UA SDK and I add this endpoint, and then what happens is I have, oh, of course, sorry, I forgot. I should have added this instance. Apologies for this. So what I'm doing here is now I can add, as you can probably see, here in Eclipse, I can add source variable, you see something, source variable example. So let's say ex1. I restart my server. Voila. And then I refresh this here. I rebrowse. And I find my ex1, which is now it's a source variable, and it has the counter. Now, look, here's the interesting thing. Look at the value here. Value is 1. Oh, guys, sorry, I forgot to say this button not implemented OPC-UA good. This will fix in a second. But look what happens. Can I actually subscribe to this? No, I cannot. I cannot. And why I cannot subscribe to this? Because the source variable doesn't have anything like current state, okay? So there's like nothing that would keep you know, like reflecting this current state. Like I really need each time to read this value on request. So look, the value is 1 at this stage, so it's in red because I forgot to change the return code. But when each time I actually, you see, each time I refresh it, it's getting a unique number. Okay, each time it's really getting a unique number, which means that as long as this piece of code that executes here in read counter is kind of atomic, so the CPU will not, you know, concurrently execute the same thing. As long as this is happening, and this we can enforce in Quasar, okay, will be covered in one of the next lessons. Of course, you can add here like a normal mutex or semaphore, but there's also a nicer way to do that. But as long as this happens, each number will be unique. Okay, so that was what I was trying to illustrate in this simple example. So other typical applications of source variables is performing either API or hardware transactions on every read or write. So many applications that I personally worked with involved embedded systems with like SPI or I2C or USB or JTAG or stuff like that, where each read or each write was not really stored in memory because this did not really make sense, but each value write would actually pass this value over one of those interfaces to, you know, whatever would be connected to your machine. Also, all applications of connecting stateless interfaces to OPC-UA variables is also fits pretty nicely the source variable. And one of the primary uses, as I told you, will be when we learn how to run this in asynchronous mode, which will be covered in part 15, but I think it was really important for you to show you the basic principle. And for your information, of course, you have the full freedom. You can also say that you don't want address space read. So there can be in Quasar a variable, a source variable that you cannot read, but you can write to it. Okay, it's entirely legal and entirely supported by Quasar. So that was part 14 on basics of source variables. I hope you liked that. I hope it was useful, and see you soon in part 15.